Can we start the session?
Yeah, please.
Good evening, everyone. I'm Aravind, a technical trainee at Wings of Aero. It is a glorious moment to extend my warm wishes on behalf of the Wings of Aero. I would like to explain the TEMS Era platform and our previous chief guest. TEMS Era is India's large digital learning platform that provides advanced learning and research opportunities for science and engineering students. Mr. George Salazar, NASA Engineering at NASA. Mr. Salazar has over 30 years of experience in telemetry, communications, speech control, command and data handling, audio displays and controls, intelligence, lighting, projects management, and systems engineering. He was delivered his session challenge of a future space mission in our platform. Jim Cantrell is an American entrepreneur, mechanical engineer, and road racer. He is the CEO and co-founder of Phantom Space Corporation, which seeks to build space transportation technologies. He was delivered his session space systems to launch 100 satellites on our platform. Mr. Roger Hunter is the program manager for the NASA spacecraft technology program, where he oversees the progress. He was delivered his session on NASA's small satellite and Kepler mission on our platform. Daniel P. Reimer is an aerospace design engineer widely recognized as an expert in this field of aircraft conceptual design engineer, aircraft configuration. He was delivered his session on the Reimer's manned Mars airplane on platform. I want to convey my heartfelt gratitude to Mrs. Usha Rani, Assistant Professor, for accepting the invitation and presiding over the seminar on online resource for performing electronics practicals. The webinar was conducted and organized by Wings of Aero for the science and engineering students to gain insight and information that would remain effective in their research and projects. All courses are available at temsera.com. Ma'am, thank you, ma'am. Can you start the session?
Yeah, okay. Is it audible?
Yes, ma'am, audible.
Okay, thank you. Thank you. Very good evening to everyone. I welcome you all to this webinar. So, can I share my screen?
Yes, ma'am. You can
Oh,
share.
is it visible?
Yes, ma'am.
Okay, thank you. So, the topic today I have taken for this webinar is online resources for electronics practicals, that is, lab on screen. So, how to do the practicals on screen? I'll just give you a brief introduction about some of the online resources that are available, with the help of which you can do the electronics practicals. Mr. Aravind,
Yes, ma'am.
if any issue is there, if it is not audible or if you are not able to see my screen, please inform me. No?
Okay, ma'am. Okay, ma'am. I will inform you.
Okay, thank you.
Thank you, ma'am.
So, before beginning this session, I will give you a brief introduction of what we are going to do today. So today we will first see just an overview of as to why we need these online resources. As we all know, we do regularly practicals. All the students they will do the practicals in the lab in the college. But now we are moving on for online resources. So what is the need for these online resources? First, we will see about that. Then, we will see some online resources. Today, I have taken three online resources: Tinkercad, Multisim, and VLAB. There are many other online resources available. Then, at the end, we will see what are the applications of these online resources, as to what are the advantages of using these online resources. So, let us start. So, first, why do we need online resources? See, the first thing is in many colleges, uh, all the apparatus required for all the practicals will not be available. The reason may be many things, financial issues, or any other things. Okay, there is a lack of apparatus in many of the colleges. Not only this, maybe whatever the apparatus is required, everything may not be there. See, like in colleges, we do practicals only pertaining to the syllabus. If anything you are learning in the theory, you want to test it, you want to see practically how it happens, then you need to have apparatus. So these online resources can be used for learning these concepts which we are uh, seeing in the class practically online, even if we don't have any apparatus with us. And also maybe at some places, if there is a lack of well trained faculty, also there are online resources where they will give you the theory also that is required to know or to perform the particular experiment. As to, it will give you the theory whatever is required to perform the experiment. And why we are going for these online resources, the most important reason, or the main reason I can say today, is the physical distance. In the pandemic situation which is going around the globe, physical distance has become a very important factor, because of which all the classes and everything is going online. So because of which we are shifting to these online resources, as to teach the students from the faculty side as well as from the student side to perform the experiments from wherever they are, or and from any of the devices. So the first online resource which we will see today is Tinkercad. What is Tinkercad? It's an online free online website. It can be used for building the circuits as well as for 3D modeling or 3D designing. So you can build the circuits with the help of this Tinkercad website and also see the output. It is very simple and easy to use. You can, everyone, even small kids also can easily perform their small projects on this Tinkercad website. And also you can, it is very helpful in doing the projects or checking out the circuits with the Arduino especially. So this is very helpful for those who want to do any project with Arduino. Like they can beforehand test the Arduino project on the Tinkercad, and later on they can go for the practical realization. So let me show you this Tinkercad website. So this is the homepage of the Tinkercad website. Okay, where you will have even there are videos available for this, where you can learn how to build the 3D designs and how to build the circuits with the help of the code blocks. It also has some code blocks with the help of which you can write the program directly, or you can write your own program. And then circuits are there where you can simulate the circuits, assemble the circuits, and see the output. And as I told you, this can be used for 3D designing also. So first we have to log in into it. So we'll click on sign in. You can log in with your mail ID. It's loading. So this is the login page once you log into it. So left side, you can see here there's an option for 3D designing, circuits, code blocks, and there are some lessons available. And whatever circuits or the designs you do, they will be available here. These are all the 3D these are the only the 3D designs which are made through this particular login. And also for faculty, you can create a class and assign the projects to students, and we can monitor the performance of the students through this classes option. So let us go to the circuits now. You click on circuits. So here, whatever the circuits are previously done by you, they all will be shown here. Then if you want to create a new circuit, here you are seeing the option create new circuit. So click on create new circuit. Okay. So here we can design our circuit, and right side you can see These are all the components that are available. Almost most of the components are available. So you can select here components. See, it has basic, all like starter components, and all Arduino related components. You can select any of them. So if you click on all the components available will be shown to you in the list. Then here you have, if you are taking any component, say for example, if I take this slide switch here, you can rotate this with the help of this option here on the left side you are seeing. If you click on rotate, it will rotate the device or the component. Select this component and click on this delete. You are able to see the delete option. With the help of this, you can delete the option. And this is the name of the circuit. You can change the name of the circuit and you can save it. And also, you can make this particular circuit available either only to you by making it private, or to everyone by making it public. And here this is the simulation button. Once the circuit is set up, you can click on the start simulation button and see the output. So for this session, we will see the half-wave rectifier circuit with the help of Tinkercad. So this is the half-wave rectifier circuit. What is a half-wave rectifier circuit? It will convert the AC voltage into DC voltage. So on the left, and it uses one PN junction diode, one resistor in series, to which you will connect the AC input, and the output would be unidirectional current. So this is your input waveform, AC waveform, and this is the expected output. So let us connect this circuit and see the output. So here you can, on the right side, you can see the search bar. You can type the name of the component. Okay. So I want to connect this on a breadboard. So when you click on breadboard, or when you search for breadboard, there are the different breadboards available. Okay, you can take any of the breadboards. Just click on that component. And you can move the component also like this. Okay. Then I want a diode. So search for a diode. So this is a diode. And when you keep your mouse over the component, it will show you the anode and cathode also. So I want to rotate this component. So let me rotate it. Yeah. And you will place this onto the breadboard. Okay, so we have connected a diode onto the breadboard. Next, I'll take a resistor. Just type resistor. Yeah, this is the resistor. You can also see the color coding. The value is 1 kilo ohm, so it will show the respective color code. If I change the value 10K, it will change the color code. Similarly, if I say suppose I'll give it 100 kilo ohm, so you can see that the color coding of the resistor is also changed. Now I'll connect this resistor. Okay, then what do we need? We need a AC power supply, okay, AC voltage. So I will take a function generator. This is a function generator from which we will give the AC voltage. Then I will see the output with the help of an oscilloscope. So type oscilloscope here. This is the oscilloscope. So take the oscilloscope also. And also for these components, it will show you positive and negative. When you keep your mouse over it, it will show you which is the positive and which is the negative terminal. So in the circuit, you see here, this positive of the power input should be connected to the power diode. The negative of the diode should be connected to resistor. And again, resistor is connected to AC voltage. So let me connect it. To connect the components, what you have to do, you have to click on the particular terminal, just click on it, the wire will get connected, and connect it wherever you want to connect. So I will connect this positive. So just click on this and drag your mouse wherever you want to connect it. Okay, so this is the positive. Now you can change the color also for this wires. If I want to make it red, I can make it red. Then this resistor, diode should be connected to resistor. So click on the diode other terminal and connect it to resistor. Then I will connect the resistor to ground. Let me take this second line from the bottom as the ground. So this will be my ground. Then again this negative also I will connect it to ground. So our circuit is complete for half wave rectifier. Now we will use this oscilloscope to see the output. So first we will connect this to the input. I will show you input as well as the output voltages. So to see the input voltage, I will connect this at the input side. So this is positive, then negative. As usual, I will connect it to ground. Then I'll take another oscilloscope to see the output. So this is my oscilloscope to see the output. This is the negative of the oscilloscope connected to ground. Then this positive I'll connect it to the resistor, across the resistor. So these are the connections, and for this component also at any time even after connecting you can change the values. So let me set the values of the function generator. I'll make the input frequency as 50 Hertz. The DC offset make it 0, and let this the input be a sine wave. So once the circuit is connected, click on start simulation. So this is the input and this is the output. So you can change the time scale of the oscilloscope also. I will change for this. Just double click on the particular component. It will show you the values. So you can see here this is the input AC voltage and this is the output unidirectional current in case of a half wave rectifier. So again you can stop the simulation by clicking here the stop simulation button. So like this you can build the circuits and see the functioning of it. If you are doing any project, you can see whether the particular project will work or not by connecting it with the help of these online resources and check whether it is functioning properly. Then you can go for the actual building of your project or the circuit. And even if you are learning anything in the theory, you can see the actual working of the particular device or any particular circuit with the help of these online resources. Even if you don't have the apparatus with you, you can use these online resources. Let me show you one more example in this. This was a very simple circuit which I showed you. So these are the different, you can even use this for Arduino. This particular circuit is about connecting a 7-segment display to Arduino. So this is a 7-segment display. This is the Arduino Uno board. So click on simulation. So you can see the 7-segment display is showing you the numbers 2, this is 3, 4, 5, 6, 7. So like this, even the complicated projects or the circuits with the Arduino can also be done with the help of the Tinkercad. Here you can write the code. See, this is the code for this particular program. You can directly write the code like this in the help of with the help of the text in a text, or you can use the blocks also. So with the help of the ready-made available blocks, you can write the program. So you just have to learn how to do it. Okay. So this is about your Tinkercad. Is it audible? And I hope it is clear.
Yes, ma'am. It's audible.
Thank you. So this was about your Tinkercad website. Then let us move on to the next one, which is Multisim Live. Many of you would have heard about Multisim, which is actually software, licensed software from National Instruments. They also have an online version called as Multisim Live. This Multisim Live can be used online. It's an online simulator from National Instruments, and this is also similar to other online resources. It has more number of components, I can say, compared to the other online resources, and it can be accessed from any computer or any mobile device also. And the best thing about this multisim is it will function exactly like the licensed version of the multisim software, but here no need for installation of any software. You just log in with your credentials, just give your details, name and email ID and all other things. Then you can start building your projects. You can live stream them onto the device. You can take the actually the import the graphs also, images in the form of images. There are many things which you can do with this multisim live. So let us go to the multisim. This is multisim.com. This is the homepage of the multisim. So here you have to log in. When you click on login, it will ask you few details like email ID and all other things. And once you log in, this is how it will look. Okay, this is the login page. Okay, here you can create circuit and you can see the circuits which are built by others also. So you can search for all the other circuits and you can try to see how the circuit is working and all other things. Okay, so I'll show you the different options in this. So click on the right side here top, you are able to see this create circuit. Click on create circuit. So this is your circuit page. Okay, so, and like others here also you can give some name to the circuits. I'll give it as example. Okay, this is the on the left side. These are all the components that are available. These are the first one which you are seeing is the analysis and annotation. You can see different and probes are available. Then this is the schematic connectors. Then you have voltage sources. You have AC voltage, AC current, then DC voltage, DC current, different types of input voltages. Then these are the basic components like resistor, capacitor, inductor. You have op amps, analog devices. Then you have diodes, transistors, indicators, switches, then modeling blocks. Then you also have digital or an and nor gate and all other things. So you just have to click on the component same as it is, then you can insert it, you can connect it, and you can see the output. So for this I have taken the example. I'll show you. I want to show the inverting and non-inverting amplifier with op-amp 741. Okay. So what do you mean by inverting amplifier and non-inverting? Inverting amplifier means whatever the input is given to the inverting terminal, it will be appearing at the output in the inverted form. Non-inverting, whatever is the input, it will appear in the same way at the output. So we will connect this circuit. So we need one op amp, two resistors, and one input voltage source, and then we'll see what is the output. So first let me take the op amp. I'll take this 3-terminal op amp, click on it, and then just click on the page. Then input voltage, click on the voltage sources, and then click on AC voltage. Then I need resistor. Now for I need one more resistor. So for that, what you can do is, for any component, if you want another copy of it, just click on the component, and then here you are able to see here duplicate. So just if you click on the duplicate, you will be able to see another resistor. I'll click on this duplicate. I got another resistor. So you can just rotate this also, resistor also, you can flip it. So these are the different options available for all the components. Then I need ground. So I'll take one ground. You can move the component also. Now I'll start connecting. So in order to connect this, okay, you click on any component and then just keep your mouse over the terminal. You can see that wire bundle like thing is appearing. Then just click on the terminal and then click wherever you want to connect it, like this. Then if you want to delete the connection, you simply select that connection and then delete. I want to rotate this particular component, so I'll just rotate it. But yeah, because I want my inverting terminal to be at the top. So now, inverting terminal, I'll connect to resistor. Then I need another ground, so I'll just copy it, create another copy of it. Then this voltage source, I will connect it to resistor. So just click on this terminal and then drag the wire to wherever you want to connect to. Again, select this component, keep your mouse over the terminal, click it and click it to the other terminal wherever you want to connect it. So to the inverting terminal, we have connected the input voltage. Then non-inverting, I'll just connect it to ground. Then this resistor, it's a feedback resistor connected to inverting terminal and the output. So our circuit is ready. Then here on the top you can see the options schematic, grapher and split. Grapher will give you the output graph, and if you click on split, the window will be split into two parts where you can simultaneously see the schematic, grapher as well as the output. So for that, in order to see the output, I need a probe. You have to connect a voltage probe wherever you want to see the output. So I'll first click on this voltage and take the voltage probe and I'll connect it to the output, because this is where we are going to get the output. I want to see the input voltage also. So I'll take another probe and I connect it to the input side. Now I'll click on split. So you can see the window is divided into two parts. Left side is our circuit, right side will be the output graph. So how do we simulate? Here you are able to see the run simulation button on the left side. Click on it. So you can see the output. Okay, see here the circuit, if you see, the probe in green color is connected at the output and it is written as VR1. Similarly, here it is probe 2, which is blue in color, is connected to the input voltage. That means in the graph, the blue waveform which you are seeing is the input and the green one is your output. Okay, so you can see that this is acting as an inverting amplifier. How it is acting? So if you see your input here, it is on the positive side. It's a positive going voltage. Whereas at the same given time, the output is the negative going voltage, or it is on the negative side, or it is inverted. So likewise, you can see the output which is inverted with respect to the input. So, and again, if you want to change any values, see for example, I want to change the frequency, just input frequency, just double click on it, click on this. So you can see here the voltage, the frequency, you can change the values, you can change the frequency value, you can change the voltage value. And here also for the even for the resistor, just click on double click on the resistance. You can see here on the right side, either you can change the value here or you can change it through this here. Just click on into 10, it will get multiplied, the value will get multiplied by 10. So like this you can change the input voltage values also, or the resistor values, sorry. So here, if you want to change the settings for this graph, first you click on the graph, then you click on the settings here. So these are the different options available for the settings of the graph. So you can set the maximum voltage, minimum voltage of display. Okay. So like this, you can see the output. I'll just remove this. This is the AC voltage. Let us take a triangular wave, or let us take a square wave. So for that you take the clock voltage. So instead of connecting a sine wave, I will connect a square wave now at the input. Then let me see what will be the output. So here in the circuit, I have connected only the probe at the output. I did not connect any probe at the input. So you cannot see the output and input together. So for that again I'll stop simulation, take another probe and connect it towards the input at the input, so that we can see directly the both the waveforms, input and the output waveforms. So the graph is not clear. I will change the values. So you can see here the blue probe, blue color probe, or PR2 is at the input. So this blue waveform is the input waveform, and the green probe is the output. That is, the output waveform is in the green color. So whenever the input is high, the output is low. Whenever input is low, the output is high. Hence, we are able to see how the op amp is working as a inverting amplifier. Let us quickly see how it works as a non-inverting amplifier. I will quickly connect it. So for that, what you have to do, you have to connect this input to the non-inverting terminal. Sorry. So non-inverting terminal connected to input, ground this to ground. Okay. Then for the input we need a probe. So this is the connection for the non-inverting. The input is connected to non-inverting terminal. Click on run simulation. So now you can see that when the input is high, the output is also high. When the input is low, the output is also low. So in this way, it will work as a non-inverting amplifier. So this is about your multisim, and you can take export this graph also. So here you have a option, right side, export. If you click on it, export graph or image, then you can export the graph or the output as well as the schematic image. If you click on graph or image, the graph will be downloaded. So this is the waveform, output waveform as well. Whatever is the waveform available, that will be imported as an image. Like this, you can take the schematic also. Schematic image, export schematic image. So you will get the circuit also. There are many other options also available. You can just go through it, and it has a large variety of components which can be used for designing different circuits. Even the complicated circuits also you can design easily once you learn how to use this multisim. So this is about multisim. It's very useful for doing the online circuits. Then let us move on to the next one, which is about VLAB. This VLAB is an initiative from the Government of India, the Ministry of Human Resource Development, MHRD. And the main aim of this VLAB is to provide access to the labs in various disciplines of science as well as engineering. In VLAB, you will find the labs related to even different fields of engineering. And it, along with the circuits, it will also provide you the necessary theory and the procedure how you have to do the experiment. All the things are given in the VLABs. So this is from the Government of India. Let me show you. Click on vlab.co.in. The website you can go for is vlab.co.in. So this is the website. Here you can see what are the different areas in which V labs. V stands for actually virtual. So in virtual labs, what are the different areas which are available? Electronics and communication, computer science, electrical engineering, mechanical engineering. Even you have biotechnology and biomedical engineering. So you can just click on any area, then you will be able to see the different types of labs in this. So I'll click on electronics and communications. So in this electronics and communications area, what are the different labs available? You will be able to see fading channels and mobile communications, advanced network, analog signals. So these are all the different labs that are available. And the right side you can see which are the different IITs which have developed for this particular lab. So today we will see RC high pass and low pass circuit, which is available in the basic electronics lab. So you can see the reference books also for the particular lab which are given here. Okay, so click on basic electronics lab. Click on this so that you can see the list of experiments. So it just gives you a brief introduction about this particular lab. Then you have list of experiments, then instructions, what is the technology used, and all other things. Click on list of experiments. These are the different experiments that are developed under this particular lab. Familiarization with resistor, capacitor, half wave rectification, full wave rectification, RC frequency response, RC differentiator integrator, etc. So click on RC frequency response. So this gives you the theory, the objectives of this particular experiment, how the circuit works as a filter, So you can just go through the theory also so that you can understand the working of the circuit in a better way. Then it will give you the procedure also as to how you have to do the experiment. So this is the circuit for the RC frequency response, and this it will give you the steps how you have to do. You can just follow the steps, and this is the simulation. So click on simulation. So here some of the experiments have the options like directly you can do the experiment or you can draw the circuit also. So click on RC low pass filter. So the circuit is already connected here. So these are the different values, value of RL, CL, input voltage, input frequency, and this is the table. So once you take the reading, you can directly note it down in the form of the table here. So first we will set the value of resistor. Let us say suppose 2000. Then capacitance value. You can select any value. Then the input voltage 5 volts. Then frequency. We will start from 50 hertz. Then click on add to table. So it will give you what is the input frequency and what is the magnitude output, then phase, then what is the output voltage. Then now you change the values. For given value of R and C, I will change the F value. Then again, now the value is 149. Click on add to table. Then you will get the value. Then like this, you can keep on changing the values and take the readings. So you can see that as this is a low pass filter, you can see that the lower frequencies are available at the output, and as we go to the higher frequencies the output voltage is decreasing. Then you can plot the graph also. Here you have the option. Few of them have this option, all experiments will not have. So click on frequency response. So this is the frequency response curve. The output, I can see that the lower frequencies are available and it is blocking the higher frequency values at the output voltage. So this is how you can just do the experiment using virtual labs. Then like this you can do the high pass filter also. It's the same way. You can just take the values and you can plot the graph and just vary the frequency and then plot the graph. So click on plot frequency response. So this is the graph for high pass filter. Higher frequency components are easily the higher frequency components are allowed at the output. Lower frequency values will have more resistance offered at the output. So like this, and if you click on this draw circuit version here, you have to connect the wires. You can have to make connections. See, you have to connect the wires and then take the output. How you have to connect it will be given in this instruction. So just see the instructions, connect the circuit and take the readings as we did for the other one. So like this you have different labs under this VLAB and also different say different types of like labs available for all areas of engineering. Even the biomedical and all other things are also available. Biotechnology, civil engineering, physical sciences, chemical and mechanical engineering is also available. So you have different labs in the particular area and then different again if you open this you will get the different experiments in this. So this was about your V labs. Then what are the applications or what are the advantages of using these online resources. The best thing about it is you can use it anytime, anywhere. You need not have a particular apparatus with you to build any circuit. And more important, what I feel is it is mostly useful, especially when you are doing projects. Like instead of doing a project physically and then testing it, and if it doesn't work again, some components you will have to buy again and again. So instead of that, you can just test these circuits online. If it is working, then you can physically go for the building of the project, and you can use this particular online resources for demonstrations of projects also. Then whatever theory you are learning, see whatever the topics you learn, like transistor characteristics or RC phase shift or many other things. So all the circuits whatever you study, you may not do in the lab. If you want to see their functioning, then you can do it with the help of these online resources. And also for any given circuit, if you want to change the resistor or capacitor's values, and if you want to see how it will affect the output, see without any damage to the circuit, if you want to study the effects of those components, you can easily do it with the help of these online resources. It will not cause any damage to your apparatus. See, in the lab, if you want to do all these testings, and if you replace the resistors with the higher values and other things, there is a chance that the circuit may get damaged. But in the online, that chance is not there. So basically, I feel this can be more helpful for people who do projects where they can test their circuits beforehand. And also in this pandemic situation, it can be used to study or learn the concepts which you are seeing in the theory. Practically, you can see their output. So this is it. And if you have any queries, you can ask. And this is my email ID. And you can find more of these circuits, some of them. Okay, not many, but few are available on the my YouTube channel, which is named as Physics and Electronics by Usha. And I would like to thank the team of teams of Aero for giving me this opportunity. Thank you very much. And any queries, if you have, I
Ma'am,
can.
I think one question in chat box, ma'am. Wait for that.
Yeah.
Can you check the chat box, ma'am?
Okay. I just see. In Tinkercad software, we have used drone coding values and their circuits. I didn't get, is it a question or what? We have used donor coding values, or we have, with the help of drone and all. I didn't get the question. If it is more clear, I can answer.
I think drone customization is used in this CAD software, ma'am.
Possible to use. With that to that level, I didn't check it. I think I actually, if you want to use it, you should have that particular component available. With the Tinkercad, some components are not available. All the components, if they are available, it's well and good. You can do it. But I don't think anything can, with the help of drone, can be done. Maybe some small circuits which are needed for it. If you want to see that, you can do it. Just see the components what you need. If it is available, it's well and good. Arduino, it's the best option. I can say you Tinkercad. It's very good for Arduino.
Okay, ma'am. Thank, Thank you, Mrs. Usha Rani. That is wonderful session for sharing your knowledge and concepts.
Thank you.
Ma'am, can we end the session?
Yeah, yeah, yeah. Thank you. Thank you so much.
Thank you. Thank you very much, ma'am.
Okay.